Hopefully you can see my screen. Xavi, can you just confirm?
Yeah, we can
Cool.
see the screen. Thanks.
Great. So yeah, thanks Xavi, and hi everyone. So before we get in the keynotes, as Xavi said, we're going to start with a bit of an interactive game. There's no pressure with this, no expertise required. It really doesn't matter if you use AI daily or you've never used it. We are all friends here. So we have 5 minutes, so it is going to be super rapid. So I need you to be awake and alert and have drunk your coffee. If you haven't, you drink that now. So as Xavi said, large language models are already shaping how climate information is explained and shared, and often in quite subtle ways. And so I'm just going to get us to explore kind of these subtle ways in which AI is creating content, and I want you to spot AI content when it's mixed in with human outputs. So I need you to be on the ball. So if you could grab your phones and scan the QR code, or Chiara's put the link in the chat. So if you click the link, that should take you straight to the Menti, or you can join at menti.com and then use the code at the top of the screen. So you all know Menti. I can see lots of you have joined already. So we have 2 rounds. So one round is going to be your eyes versus AI. So not typically using an LLM, but just to get you started. And then round 2 is your brain versus AI, where we're going to explore an LLM. So let's start. So if you haven't joined yet, the QR code will be on the side of the screen, so you can join at any time. So part 1 is real or AI. So I'm going to show you 3 images. I want you to vote for each one. This is a bit of a competition, so the quicker you answer, the more points you get. And I've put a little banana on the screen just to remind me to tell you that I have used Nano Banana. So this is Google Gemini's AI image generator. So if you haven't explored image generators, I'd ask you to kind of explore Nano Banana. It's one of the better ones out there for producing images. So let's start with the quiz. So it might ask you to put a name in, or something. You can be anonymous. So if you want to be, I'm Johnny the Mouse. So yeah, you can be anonymous. I'll just give you a few seconds if you want to put your name in, or just to create an avatar. All right, so we're going to start. So get your fingers ready. Remember, the quicker you answer, the more points you get. So I want you to look at that image and think to yourself, is that AI generated or is that human generated? So if you're on your phone, just scroll down and you should see the option to click whether it's real or AI. Okay, most of you voted real, and that's quite nice to see. So this is an image that we took when we went to visit tea gardens in China. So I can tell you for a fact that that is a real photo. So well done to those of you who spotted that that was real. On to the second image. So this is an image of a drought landscape, so a field that's undergoing drought. So again, if you could answer whether you think that's AI or human generated. Oh, a bit more of a split. So yeah, those of you who said AI generated, you're right. I wanted to use this image because this is an image that's used quite a lot when we're talking about kind of drought. So you can see how well that AI is now reproducing these images. So yeah, well done to those of you who said AI, but also it's okay because it does look really real. So it doesn't matter if you said real. Okay, the next one is a little bit trickier, hopefully. Yeah, those of you who said AI generated, you're correct. So I actually asked Nano Banana to depict a Climate Europe event, so you can see the banners and stuff. And I think it's actually done a really good job. So there aren't any weird like 7 fingers on one hand, which are usually the things that come up with an AI generated image, and it's pretty spot on. Those of you who are a bit more observant might have seen in the bottom right hand corner the Nana Banano watermark. So that I left that in on purpose just to see who was most observant today. But yeah, you can see that the image generation is pretty spot on, and I'm really impressed with how accurate these images are actually. So yeah, well done to those of you who said AI generated. And then the winner, oh, it's very tight. Yay, Droopy won. So well done to Droopy. You are our AI expert this morning. Great. So we're just going to move on to part 2 very quickly. So this is where I've used an LLM. So in these particular examples, I've used Copilot. So Microsoft Copilot. So in this, I'm just going to show you 4 quotes. This isn't a competition, so there's no stress on that. So each of these quotes that I show you, it sounds like it could be from a real climate service publication. Some of them are from a real climate service publication, and your job is to think about whether a human wrote this or an AI generated it. And then the part that I want you to interact with is how confident you are. So there'll be a sliding scale, and I want you to put how confident you are in terms of if you really think it's AI or if you really think it's human generated. So the first quote is, standardization within climate services should be understood as an enabling mechanism for interpretability, comparability, and quality assurance rather than prescriptive uniformity. So you should still see that on your screen. I want you to vote or slide along the scale how confident you are that that is a human created quote or that's an AI quote. And in the middle somewhere it's like unsure, and then you've got leaning human, leaning AI. So I'm just going to give you 5 seconds to kind of think about that. As I said, we need to be a bit rapid. So I'll just wait for a few more of you to respond. There's no right or wrong answer. Well, there is a right or wrong answer, but we're not judging your answers, because I just want to show you how hard it is, or how good it is, how good AI is at the moment in producing these kinds of responses. So you can still answer. I'm just going to show some of the results. You can see we're slightly leaning towards AI, which is all right. So spoiler, this is an AI generated text. So you'll definitely find this kind of sentence in a real report. And that's kind of what I wanted to emphasize, is that AI is really getting that structure right, the vocabulary right, and the logic is pretty right. So yeah, but no such publication exists that I am aware of. So number 2, climate change becomes relevant for regional impact management and for risk assessment when changes in mean conditions or episodic events affect natural and societal assets positively or negatively. So a very long quote there with no commas. How confident are you that that quote is definitely human, not sure, or definitely AI? Yeah, I'm just going to give you 5 seconds. Okay, again, slightly towards definitely human, which is good because this is a real quote. So I took this from the IPCC, Chapter 12, Climate Information for Regional Impact on the Climate Services area. So definitely human from the IPCC. Third one major problem for the equitable development and uptake of climate services is that there is evidence of unequal quality of many of the existing climate services in the market. So again, how confident are you? Is it definitely human, definitely AI? Oh, okay. Edging towards definitely human. So yep, so this one, you're right, it's definitely real. So Marina will hopefully, I don't know if Marina's in the call, but Marina actually wrote that quote as part of a deliverable for on a framework to support equitable standardization. So Marina will be very happy that you spotted that she actually wrote that. So yeah, well done, everyone. And then lastly, co-development is most impactful when embedded as an ongoing operational principle supported by clearly defined roles, responsibilities, and feedback mechanisms. So yeah, how confident are you that the last quote is human, AI, or you're just not sure? Hopefully this is showing that it is quite hard to spot AI and a human written content, and yeah, just showing you how good it is. Okay, definitely AI. Yeah, might have spotted the pattern. So yeah, that one is AI generated. But what's crazy about this one is that I created this quiz a couple of days ago, and it pretty much copied what we were talking about in yesterday's Websterful session around frameworks and feedbacks and defining roles. So it has got it pretty spot on, which is pretty spooky, I think. So yeah, that's it for that part of the session. I hope that has got you ready for the upcoming conversations around AI, especially large language models, and got you thinking about how we might be using that in climate services. I'll be back with you after the keynotes when I'll be challenging your thinking a little bit further and asking for your help. So yeah, hopefully you found that fun. I'm going to stop sharing and pass back to Xavi.
Thank you very much, Stacy. That was very interesting. So next we have Marina Weiss from the BSc. She's going to be presenting some legal aspects about AI in Europe. So Marina, sorry, Marina, the floor is yours whenever you want.
Perfect. Let me share my screen. I'm having a bit of a connection problem, so I might leave my camera off and turn it on for questions.
Okay, no
Perfect.
problem.
Perfect. Okay, so thank you all for coming today. Let's find out what's going on with AI in Europe. I wanted to start this session just by showing this slide because it's a good reminder that we've asked ourselves the same questions, we've had the same concerns regarding computing, making critical decisions. This is from an ABM training manual from the 70s. And over 50 years later, we're having the same conversations and the same concerns about accountability and transparency when AI is making critical decisions. So the AI Act is a risk-based regulation. This means that the obligations that will apply to you when you're developing your system will depend on the level of risk that your system has based on the risk classifications of the Act. As you will see a bit later, these classifications are a bit static, and this is already having some problems with agentic AI, which is dynamic instead of static. So we will talk about that a little later. I just wanted to state here, you can see some examples. But it's important to remember that the AI Act doesn't substitute or replace existing laws. So for example, if you use personal data to train your AI, the GDPR will still apply, and liability directives will still apply regardless of the AI Act. So they run in parallel. They don't substitute each other or replace one another. Okay, so throughout the act, you will see these two words. You will see systemic risk and high risk. So I just wanted to take a minute to explain how are they different from one another and what they actually mean. So systemic risk is based on the potential damage that the AI system or model could cause. And these risks have to be of large scale form. So this means that they can be propagated quickly across society and they have a large impact on public health, safety, public security, or fundamental rights. And that this damage is reasonably foreseeable. It means it's not hypothetic, it can actually happen. And this harm has to come from either the most advanced models, which are models that meet a certain threshold of compute. You can see here the actual numbers, but also it can be from models that have equivalent impact. So this means that not only will the largest or most compute powerful models have potentially systemic risk, but other models that have an equivalent impact may also have this systemic risk. And the commission kind of reserves a right to say, okay, this model might not meet the compute threshold, but it can have reasonably foreseeable systemic risk. And so we will treat it as such under the Act. versus high risk is based on the need or application that your AI system is trying to fulfill. And it's making consequential decisions about education or employment, right? So this means an AI deciding whether you get hired, whether your CV gets looked at. This means an AI deciding whether you can open a bank account or getting a loan from a bank, or an AI deciding whether you get a bed at a hospital, for example. So all of these systems, because they are making consequential decisions on these areas, they are considered to be high risk under the Act. And so you have more obligations under the Act. We will also talk about the human oversight component in a later slide, as that is also important. So here is a way to illustrate how the higher risk your system is classified as, the more obligations you have to comply with. You can see at the very left, you just have an obligation to basically educate your employees that are developing or using AI as to what AI actually is. Versus if you are developing a high-risk system or model, you need to implement a high-risk management system. You need to establish human oversight measures, meaning a human actually has a mechanism to operate or disable the AI. It can actually check the decisions. You need to log everything. So as long as the system is turned on, you need to record everything. And you need to have really robust technical documentation. As you saw before, generally GPI models, because of their widespread use, they are embedded across technologies and verticals. So they're used in legal, finance, and everything. They are largely considered with systemic risk, but some might not. But you can see that they made a special category for them. This is a legislation that was very based on LLMs and GPI models as the first ones to come out and be available in the public. And now they're starting to come across problems when they apply it to agentic AI. Okay, this is also a basic example, so you can see that risk level also may vary depending on the application of this AI and the level of autonomy. So on the left, you would have a chatbot that basically gives you recommendations on whether to wear sunscreen or not based on the UV rays of the sun. And this would be considered a limited risk because it's basically an informative recommendation. You would still need to provide information about how this LLM was trained. So which data is it using to give you the responses, give you these recommendations, and why? Why is it giving you recommendations on some days and not others? And then the other thing you would have to ensure is that you inform the people that this is an AI giving this recommendation. It's not a panel of experts. It's not a human. It's a chatbot. And this would be considered limited risk. Whereas on the right, you see an AI model that has an automatic application. So it automatically sends alerts to millions of people that there's been a flash flood, and so the roads are closed. Roads are critical infrastructure, right? So anybody that receives this alert on their phone is going to make a decision. Am I going to use the road? I'm not going to use it. If I'm on the road, what am I going to do now? So it has immediate impact on a critical infrastructure that impacts people's livelihoods immediately. So it is considered high risk. And if there is no mechanism within the system that allows humans to monitor and intervene in case the system malfunctions, then it would be forbidden. You would be not compliant, and so you could be subject to fines, for example. Okay, another point to take into account is that the obligations of the Act are triggered when you put the model on the market. So what does this mean? It's a term that can be pretty confusing because it doesn't mean that you are charging people to use your system or model, which is basically OpenAI, ChatGPT, Claude, etc. It also means that you are putting your model in a public repository for other people to download and use. So try to think about these things. It doesn't mean that you are charging people. It means that the model is public and anybody can use it. And they do this cutoff point because as soon as the model leaves the lab where it's controlled, you have a number of users that are using it, the use is more or less limited to, the risk is kind of contained. As soon as you put the model out there, multiple users can use it. Risk is no longer contained and may spread fast. So the bottom line is once the model is public, you cannot really put the toothpaste back into the tube. We saw this with ChatGPT. They made it public for the whole world to use with limited information, and now we're kind of starting to see some of the consequences of that as well as the advantages. Okay, I also wanted to talk about this exception that exists within the Act, because a lot of researchers have questions on, okay, I'm not making a product, I'm not charging any money for this. I just want to put it in a public repo and I wanted to put the code in open source. Do I still have to comply with the AI Act? And the answer is yes, because there is an exception, but it is quite narrow. So you would only be exempt from complying with the act if your model is not public. So you must keep it internal forever. That's already a big limitation. The other limitation is that the model only has to have been created for the purpose of internal research. So if you're making a model to make a pilot or a demo, that already doesn't meet the requirement of the definition. And the other point is that if the model is high risk, it doesn't matter that it's open source. It's high risk, and so you have to comply with the obligations of the AI Act. Okay, I wanted to finish off giving you some recommendations for data selection to train the model. The important thing is to document. So where are you getting this data? Which source is it coming from? Do you have lawful access to the data? This means that the data is either public and has a license that allows you to use it to train AI. And important also is that the provider of this data guarantees that they're basically not passing legal risk onto you, right? So they are guaranteeing that they have all permissions from all authors to publish this and that it can be used freely without risk. That there are no reservations of rights. So this means if you go to a website and it says copyright, all rights reserved, most likely you cannot use it. And we are starting to see now actual prohibitions of no crawling, no scraping, not authorized for AI training use, and also that you don't bypass any paywalls or barriers. Um, Another option is if the data is private and not public, you can also come to an agreement with the data provider. And this immediately authorizes you to use it to train AI if you put it in the agreement. Um, and then also in terms of authorization, make sure that you don't use any data that has restrictions. So to that end, we recommend using permissive licenses, so CC BY, UPL. Try to not use any data sets with licenses that might give you problems later, right? So imagine you start doing a project that you don't think about commercializing, but then in the end you want to. If you use anything with that kind of restriction, you will not be able to use it at the end and you might have to retrain. And then avoid using data from sources that do not guarantee non-infringement, because these sources are basically saying it's your responsibility. If you use it, we will not indemnify you, we will not protect you. It's basically at your own risk. Okay, and then to finish off, I just wanted to state, okay, what can we do to stay ahead? I think the bottom line is to think about no black boxes. The AI has to be explainable. You have to be transparent on which data it was trained and how it's making certain decisions, because the user has to know. So think about the technical documentation as an extension of the model card, which is already the standard. And then also think about the fact that this law is young. It only came into force in 2024, and now already they are proposing some changes to simplify it. So it'll keep going, especially with agentic AI. I think we will see some interesting developments, and that's it from my side. I'll be happy to take any questions if you have it. Thank you so much.
Thank you, Marina. That was very interesting. I currently don't see any questions in the chat. Would anyone would like to speak up and ask a question? Okay. Otherwise, I
Maybe
will ask it.
one Oh,
Yeah, go
sorry,
ahead.
one quick
No, go ahead.
question. Yeah, I mean, one problem is that a lot of these public models or open source models like Gemma from Google or also Qwen models from Alibaba are probably trained on a lot of data that is not really properly licensed. What is your kind of perspective on using these models then in that context?
Right. Yeah. So it's essentially what you describe. Since these models were not trained even in the EU, they were trained abroad. They don't have to comply and will probably not comply with the AI Act. So I would say review the conditions, but most likely they will not meet. They were not going to be trained or have not been trained on data that is permissive or that allows them to train it. So it's basically risk analysis. So depending on how you want to use this model, I would say you are assuming more risk or less. So I would say for internal research, the risk is lowered, but if you want to build something that you want to publish, the risk gets higher. So that would be my recommendation.
Yeah, thank you very much, Marina and David, for the question. We don't have more time, unfortunately, but if you have more questions, please leave them in the chat and we'll try to answer them later. Thanks again, Marina. Now we have a presentation by Ivan. He's a developer in the Alfred Wegener Institute in Germany. So thank you very much, Ivan, for presenting, and the floor is yours. Sorry, Ivan, you're muted whenever you want to speak. Yeah, no
Okay,
worries.
now it works. Great.
Yeah, we can
Okay.
see the presentation.
Can you hear me also? Okay, good.
Yeah, everything is fine. Thanks.
Great. Okay, good morning. Thank you to the Climate Europe tour organizer for inviting me. Today I want to show how our view of LLMs in climate science has changed over the last few years. They started as a text generator. Now they can already run parts of the analysis themselves. And I will focus on what is really useful and also on what still needs caution. So let me describe the recent history in three simple phases. The phase one around 2023, the LLMs as Oracle. People mainly used LLMs as a question answering system. You could ask the climate question, for example, what does the IPCC say about Arctic amplification? And the model would produce a fluent text answer, but the answer came from the model's internal knowledge with no reliable way to check it. Wrong or invented details were common, so skepticism was justified. On phase two, in 2024, the LLM as assistant, the retrieval augmented generation or RAG, made those systems more reliable. Systems such as climate Q&A and chat climate, linked answer to source documents, for example, IPCC reports again. The model could point to specific paragraphs, link claims to the source, and sometimes refuse to answer when nothing relevant was found. This was a clear improvement, but the LLM was still mostly a chat interface. It could summarize and retrieve information, but it could not do analysis itself. So phase 3, 2025, 2026, the LLM as agent. This is the stage we are entering now, and it is a major change. The LLM does not just answer questions. It can write code and run that code in the sandbox. It can process data files, query cloud data catalogs through the APIs, produce publications quality figures, and fix its own mistakes through the correction loops. They can point, so the key point is simple. The LLMs is moving from text generator to scientific work. Let me show one simple example of how an agentic system can work. Several parts work together to turn a natural language request into analysis. A user gives a request in a plain language, for example, compute the station-based NOAA index from 5 SMIP 6 models and produce 3-panel comparison figure. This request goes first to an LLM orchestrator. Usually this is a strong generator model from OpenAI, Anthropic, or Google. It's job is to break the task into the small steps. Those steps can then be handled by different agents. A data agent gets data from a source such as the Copernicus Climate Data Store. A code agent writes there and runs Python code with the tools like X-Ray, Dask, or Catopy. A RAG agent looks up scientific papers or other reference material, for example, to check how the now index is usually computed. An important part is self-correction. If the code agent makes an error, for example, dimension mismatch or wrong coordinate selection, the system reads the error message and sends it back to the LLM. So the LLM then writes the corrected version. This can happen several times until the code works. So several published systems already use some version of this architecture. Examples include Climate Agent, EarthLink, ClaimSite, and others. But this is still only a simple example, not a complete blueprint. In a real scientific workflow, you would also want to provenance tracking, uncertainty information, and verification checks. Let me now show one published example of what those systems can produce. Those figures came from a paper by Pantuchin and colleagues. The system includes a quality control loop that lets it critique and improve its own output. On the left, the agent analyzes microplastic distribution in the Waddle Sea. It retrieves ocean data, calculates surface currents, adds the sampling station, adds test and relation between microplastic abundance and current speed. On the right, the agent compares the air temperature measurements from the Polarstern, the ship Polarstern, during the Mosaic expedition with RF5 2 meters air temperature. It also generates windrows and keeps the data request fairly small. So the main point here is the self-correction loop. The first version scored only 3 of 10 in the LLM's own quality check. After several rounds of correction, including colors, labels, annotation, and so on, the final version reached 9 of 10. This ability to improve its own output is one of the most useful features of agentic systems. The previous slides showed a published example. This slide shows the prototype system from Avi called SmipForge. It combines 4 parts: RAG, data access, code execution, and figure generation. The user gives a single natural language prompt. It asks for a station-based now index from SMIP6, sea level pressure data for 5 models, comparing historical runs with the SSP5 simulations. From those, the system does 4 things. First, it looks up the standard method in the literature. Second, it retrieves the SMIP6 data. Third, it writes and runs Python code and compute the index, and normalize it and calculate trends. Fourth, it produced 3 panel figures you see here. The key point is that one natural language prompt leads to a full multi-model analysis. The user does not need to download the data or write code. This is still work in progress, but it should be published soon also. So the examples so far are really on new generation of coding agents. Let me mention 3 of them. Cloud Code works in terminal. It can read files, run commands, and make edits in code bases. OpenAI Codex runs coding tasks in cloud sandboxes and can work on tasks in parallel. The AlphaWolf is not really the coding system, but it's like from Google DeepMind, uses evolutionary search to discover them or improve algorithms. The main point is simple. Those tools change the role of scientists. You describe the analysis, and the agent does much of the coding, debugging, and execution. Now a basic question. What can LLM know about climate even without external data? In the closed book climatology study, one LLM was asked to recall mean July 2-meter air temperature at more than 15,000 land grid points. It had no access to outside data. The answers were then compared with the RFI analysis. The result is striking. The model captured the large-scale global pattern quite well. The root mean square error is about 3 to 6 degrees Celsius, and the mean bias is around plus or minus 1 degree. But the errors are not random. The model does worse in mountains and polar regions, and it misses important local details. So the message is mixed. LLMs do contain some climate knowledge, but we should not treat that knowledge as reliable climate data. That is why retrieval augmented generation, or RAG, is still important. It grounds answers in real reports instead of relying only on the model's memory. This slide shows 3 examples: Climate Q&A, Chat Climate, and Climinator. They connect LLMs to authoritative climate documents and use them for question answering or fact-checking. The good news is that RAG improves support for claims, but it does not solve the whole problem. In one recent evaluation, the share of supported claims improved from 30 to 57%. So RAG helps a lot, but carefully validation is still necessary. So I will not read the slide item by item. The main message is that there is now a real ecosystem around the climate and geoscience LLMs. On the model side, there are real published examples like Climate GPT, K2, GeoGalactica, Ocean GPT, and others. On the institutional side, the patterns and similar IPCC and other institutes are all now engaged with AI in visible ways. Copernicus is also expanding interactively climate service tools. So the key point is there is not any single model in this list. The key point is that climate AI is moving from isolated experiments to an ecosystem of tools, papers, and institutions. Of course, there are serious problems as well. The first, LLM outputs are not fully deterministic. The same prompt can produce different answers, and that is a problem for scientific workflows that need stable and reproducible results. The second style can be stronger than truth. The answer can sound clear and confident even when it is wrong or only weakly supported. This is especially risk for non-expert users. The third, reproducibility is still weak. Many LLM studies cannot be fully reproduced, and commercial models keep changing over time. Fourth, extreme events remain difficult. Those systems often do better on typical cases than on rare or unusual ones. And finally, AI also has its own environmental cost. Running large models at scale uses energy and creates emissions. So if we use those tools in climate service, we need strong validation, no enthusiasm alone. So let me finish with the 4 short points about what may come next. The first, agents may reach something close to junior researcher level on routine analysis tasks quite soon. That means that bottleneck shifts from coding to asking the right question and checking the answer. The second, RAG systems will likely connect to much larger climate knowledge bases, including IPCC, Copernicus catalogs, and model documentations. Third, some systems are already moving toward more autonomous research workflows, not just analysis. They may explore data, test ideas, and suggest hypotheses. That is exciting, but it also raises hard questions about validation. Fourth, we urgently need better validation frameworks, standards, and uncertainty estimation for agent outputs. So the central tension is clear. The systems are powerful, but the climate services require very high scientific standards. And thank you very much for your attention, and I'm very open for questions.
Thank you very much, Ivan. If anyone would like to ask a question, please raise your hand or write that in the chat. I see that there's a question in the chat from Marina Baldicera. So I will read that to you, Ivan. So
Yeah.
she's asking, how do you see the future of the discipline if tasks usually done by scientists in training are delegated to AI? Will scientists miss insights into basic things like coding and analysis?
So again, I think that the such agent systems, they definitely can significantly help in the analysis. Okay, but so it means that there's no need to write very complicated code by yourself that would take like months of work. It could be done by the agent in a couple of minutes. But the expertise the human expertise still needed. Absolutely. So it's not so there's no way that you can exchange with such agentic system the expert knowledge and expert thinking.
Thank you very much. There seems to be another question by Lucy. Um, so do you know of any instances where outputs of the systems listed have had meaningful impacts on real-world climate mitigation activities?
Not yet. No, to my knowledge. To my knowledge, no. I mean, they're quite new, so they appear mainly like last year, and that's still, yeah.
Thank you very much. I think we might have time for a last question, if there's any.
Yeah, can I ask without using the chat? This is Judith.
Yeah, go ahead, Judith.
Um, yeah, I wondered, we just had this exercise with Stacy, where we couldn't see the difference between human and AI. So you say human action is still needed, but the outsiders won't see the difference if there was a scientist involved or not. So how do you look at that?
Okay, because the text and images is one story. The another story, the analysis. So um, even if the code is well written and figure is nice, uh, you still need to be able to validate it. You need to be sure that it's truth. And here is your experience there as an expert is absolutely necessary. So you wouldn't go to the original data, you would go to the code that was written, and you need to read the text carefully. So not you following the AI suggestion, but the AI following your suggestion. Yeah.
But if you are a reviewer, you need to put in a couple of months before you have judged the article.
Sorry, can you repeat it?
If you get a scientific article and you have to check it,
Yes.
then it may take you a lot of time to see if it's real or not.
That's true. That's that I think it's the edge where we need to decide what we do with the articles nowadays. The last articles we had takes like 1 year for review, and the chat can do it in 30 seconds, right? But most cases, chat would do the not in a really good way as the humans still doing. I mean, I don't have an answer on your question. Yeah, it's highly debated nowadays. So we cannot hear you. Sorry.
Yeah, sorry, muted. Yeah, I will take Nuva's question as the last one, and then we can move on. If you have more questions for Ivan, he will participate in the panel discussion, so please keep them coming. So the question is, if a junior research delegate asks the agent a question, does he or she then need to test the answer? If the question is simple, it might be easy to check the answer, but what about more difficult questions on which there is no scientific consensus? For example, how would it be possible to test the answer without doing some calculations yourself?
You need to do the calculations yourself, but the agents can help with the writing the code here, right?
Yeah, I guess this conversation is kind of jumping into the conversation of vibe coding. So vibe coding, I guess, is getting into the field of climate services as well, and is also changing how scientists work. They don't have to rely so much on knowledge about software, but they can focus on knowledge about science. And they still have to check the code, they still have to check everything that is produced. We will talk more about that during the panel discussion. Thank you very much, Ivan, for your presentation and the participants for the questions. Now we will move on to the presentation of Maisa and Alicia. They will talk about LLM evaluation. Both of them are researchers at BSc. They both work on this exact topic, so they are really experts on this field. Please, Maisa or Alicia, whoever wants to start first, go ahead.
Alicia is starting and will share her screen in a bit.
Okay, no worries. Just let me know if you have any issue. While Alicia is trying to share the screen, I just wanted to remind you that we will have a final interactive activity during this session. So at 11, sorry, yeah, 5 minutes before 11, with Stacy to gather questions for the panel discussion. So you can wait until then, or you can leave them in the chat if you have any.
Hey, Chavi, I think Alicia is having a trouble at connecting her laptop. She
Okay.
will try another laptop. So if we can have 5 more minutes.
Yeah, sure. Atia, are you there? So perhaps we could start with your presentation and then
Sure.
go. Yeah?
Yeah, no problem. Yeah.
Okay, so Maisa, we will start with Atia then, and we can
Yes,
then
sure.
go back to you. Yeah?
Sure. Yes, sure.
Yeah, thank you. Sure. So Atia Cortez here is also a researcher at the BSc. She's an expert on alignment, and she will try to introduce us to this topic. So thank you very much.
Okay, so hello. Thank you. Thank you for the introduction and invitation. So yeah, I will give you a brief overview on some, different, especially challenges of using AI in climate service. So disclaimer, I'm not an expert on climate, but I just try to adapt slides and everything to this context. So just first to introduce, because I'm not really sure about the audience and the knowledge we have, but to give an idea, so today we are focusing especially on LLMs, but before that, when we were using traditional AI-based systems in any kind of domain, not only on climate, they were mainly used for classification or prediction tasks. Many of them were used, for example, with rule-based approaches or regressions, techniques that were kind of, let's say, easy to then interpret and also evaluate. In the domain of climate, for example, they were using for weather forecasting, also to manage climate disasters like predictions, protocols, etc., energy optimization, emission mitigation, etc. So now that we are using all these generative AI that Ivan was also introducing before, so these AI-based systems that now they can generate text, images, and then from there recommendations, for example, and interact with the users in a more direct way, in the sense that users, maybe before when they were using these traditional AI systems, they were aware that it was just like a tool, let's say a program, no, in which they will put some data and they will get some results, and the interaction was quite limited or basic. Now this is changing with LLMs, and people are having this kind of more seamless interaction with these systems, and also the kind of outputs that we are obtaining are different. So in this sense, we need to be aware that the more autonomous and the more present these AI systems are in our daily lives, we need to put also a focus on the potential impact that they have, especially when we talk about bias and when we talk about how we design these AI systems. We also need to take into account that these LLMs, these generative AI, they are very hungry in terms of data and in terms of computational power. So we need to build all these data centers to be able to collect and to store, to process all these high volumes of data that are being generated. And this is also causing a high environmental impact, especially in terms of climate and air pollution. And there is also a huge need of natural resources. It has always been there with building computers, chips, etc., but now it's more and more causing a problem. So in this sense, it's true that AI can be seen as an environmental ally. It can have a lot of opportunities for climate modeling, forecasting, for smart grids, agriculture, etc. But on the other hand, there are also a lot of consequences on the environmental cost that AI is causing. So we have what traditionally was called this Jevons paradox. In here, it's moved towards this sustainability paradox, right? We want to use this technology to have an impact on our climate, on our environment as a positive one, but at the same time, we are causing a negative one. So this is something that from an ethical point of view, it's also important to take into account when we are designing our technical solutions and to think on the kind of technology that we need, especially now that everyone is rushing towards LLMs, and maybe we need to think a little bit on the question of, do we need this, or why do I need this, and then try to build this on more conscious way. So today I'm going to talk about three main challenges of AI in general. Here I'm adapting to climate services, which are evaluation, bias, and alignment. I will focus it especially on LLMs, and how the combination of the three of them can then help enhancing this trust towards the AI solutions. So we start with evaluation. When we talk about LLMs, we talk about these language-based outcomes. As I said before, they can be interpretations of texts, or maybe we ask them to summarize a bunch of documents, to give some recommendations. So the thing here is that there is no single correct answer, because there might be different answers that are more or less answering the same, but it's not exactly the same answer. So when we are also creating our metrics to analyze all of these, to evaluate all of these, it's more tricky than with traditional AI systems. Also, we find that there are many answers that sound convincing, so they seem to be right, but in reality, they are wrong. And this is due to hallucinations, maybe misinterpretation of the data that they are using, or even that they are using outdated information, because we know that LLMs, in the end, they have these data sets. And if we are asking for something that is not there, the answer will not be, I don't know. They will just, it will just generate an answer with the data that they have, even if it's outdated. And in the end, this will give incorrect information. So as I said, it's hard to assess, first, because there is a lack of explainability. So we are working with these black box systems. As I said, we can have different answers for the same question. And so all of these make it hard to benchmark the quality of the results, especially if we think about how we evaluated traditional AI systems, more working on accuracy, right? All these kind of traditional metrics. So here it does not work only with that. We need to think about other kind of dimensions that need to be assessed in order to evaluate if we can truly trust the outcomes that we are obtaining. So the problem here is that with LLMs, we are interacting with systems that have a high quality language. So we have this interaction that seems to be kind of human-human interaction instead of human-machine interaction, but this can mask low-quality information or even misinformation. And in the end, this has an impact on having an over-reliance on the system or even to misuse it. When we talk about bias, When we talk about bias, so this is kind of a pipeline of what would be an AI-based system, traditional AI-based system. So we have this first layer here where we are generating our data based on the data that we are collecting, and then the different steps until creating our data set to then design our model and to evaluate it, and finally to release it, to deploy it, and use it in the real world environment. So here, this is an image from this paper from Suresh and all, and it identifies different sources of harm, both for the data generation and the model building and implementation phases. And today I will just briefly summarize you the problems on representation bias here, but there are many others that are important to take into account. So when we talk about the data that we are using, there was a slide before, I don't know if it was Ivan or Marina, talking about the different data that we can use, either public, private data sets, websites, etc. The reality is that this is not balanced in the representation. So here's an image to give you an idea of the data sets that were used between 2015 and 2020. For performance benchmarking. And the bigger the country is, the more the data sets coming from this country were used. So as you can see, there are huge differences, which can cause, in the end, geographic biases. So we have an overrepresentation of the global north and an underrepresentation of the global south. There is also a language bias because most of these data sets are English-centric, and then we are leaving out local languages, and then we can also lose knowledge about local contexts. And there is also a socioeconomic bias, again, with this global south and global north disparities. And in the end, we would be leaving out vulnerable communities, which also have less data because they are less represented in opposition to these wealthier areas. So we need to ask, when we are building our systems, who are we representing with this, and who then will be benefited with these systems? The risk is to under-prioritize the most vulnerable people, for example, in climate disaster situations, and to amplify, for example, the digital divide. If we are using systems that need to collect real data from, for example, sensors, phones, etc., and we deploy these in countries where there is less infrastructure, then of course we will not be representing, we will not be learning about the real context of these places. And finally, when we talk about alignment, we have built our data set, we have built our model, we've trained, we've evaluated it, no, we've tested with different benchmarks, but then we need to ask if we are making the right decisions. Because when we talk about AI alignment, we are talking about how to encode our human values, ethical principles, and also the intentions that we have with this system into the AI models. This is not an easy task because obviously not everyone has the same values or ethical principles. And here there is a complex exercise in doing this value prioritization and also to contrast the opinions of different stakeholders that will have a role with this AI system. So either by designing it or then using it or regulating or whatever. So different trade-offs that we might find are, for example, efficiency versus equity. So if we want to have very fair systems, maybe then we are losing. So they will be working better for specific cases, but then it will be more difficult to generalize. Economic growth versus sustainability, short-term versus long-term resilience. And in the end, one of the main challenges is to confront individual interests against institutional interests. So yeah, we have a big challenge here because even if we can ensure through this pipeline that we are, collecting the right data, that we are building the right model, that we are using the right data again to test, to benchmark our model, even if everything has been checked and we can ensure, even if it's really complicated to ensure the correctness and unbiased, bias-free system, this is not ensuring that we are creating a model that has the right goal, the right decision for the targeted audience, the targeted people that are going to use these systems. And then in the end, it can create some conflicts also. So it's a very hard step. But then all these trade-offs, they also cause a cost again, because having to take into account all these steps, it will require maybe more people in the teams, more hours of testing or evaluating, hours in the design. And then we also need to analyze which is the level of minimum satisfaction, let's say, that we can provide, and the level of economic commitment that we can put into developing this. So these are all decisions that we need to make. So how do we move to this responsible and trustworthy AI for climate services? So the problem is that if we are failing in one of these challenges or in some of them, then the problem is that we don't have trust anymore. Because we cannot ensure that the system is working as we want, that it's representing the people that we want, and that it's making the right decision. So some final recommendations, some of them were already presented by Marina and by Ivan. I think one of the main aspects is to educate and to raise awareness, not only on AI in general, which is what we find in the AI Act, but also about the different dimensions of AI, in particular about ethical, legal, socioeconomic, and cultural aspects of artificial intelligence, and fill the gap between the different experts, to build interdisciplinary teams and collaborations. So this is not only about who is using the data and who is regulating. It's everyone that has a role, as I said before, has to be included at some point. The technical evaluations are not enough. They need to be combined with ethical, contextual, and historical analysis of the data and of the system. And also, bias is not only a technical problem; it's more a socio-technical problem, and it's not random. It's systematic and it's structured. It's always been there historically. We have our own cognitive biases, and we need to work to try to mitigate these biases to have a better impact on society and guarantee equal benefits for everyone. Demanding transparency and accountability. Again, this is a link to the AI Act. It might not eliminate bias, but it will make it more visible and actionable. We have a challenge also here. For now, there is a lack of standards, so there are many ways of building our technical documentation, our reports, but we need to see how this aligns in the end with the AI Act. And one of the, I think, the key is that AI needs to be used as a support tool, not as the final decision maker. And that's it, because I don't know if I have more time.
No, thank you very much,
Thank
Adria.
you.
We might have time for a very, very, very quick question, if there's any. I don't see anything in the chat. No, no, any hands raised. But I appreciate a lot your presentation. There might be some questions for you in the chat later, so stay tuned, please.
Sure.
Okay, thank you very much. Maisa, Alithia, how is it on your side?
Yes, all good. I will
Yes, good.
I will share my
Sorry.
presentation.
No worries.
You're all able to see my screen, right?
Yeah,
Yes, we can see.
Perfect.
okay, thank you.
So we are Maisa and Alicia, research engineers in BSc, and we're here to talk about LLM evaluation. So why do we need evaluation in the first place? We know that if we ask some questions in different LLMs, we will get different outputs. So depending on the LLM that we ask, we get different answers. That's why we need to have some kind of measurement to evaluate the answers.
Sorry, Alicia, I have to interrupt you. I think, Maisa, you might have an open... Yeah, thanks.
Vale. Okay.
All good. Thanks.
Perfect. So depending on the LLM that we ask, there's very different outputs that can be generated, maybe more complex or maybe more simple. So the aspects that the LLM that we can evaluate, LLMs, are the next. So we can evaluate tasks like coding, and also we can evaluate model behavior. So, and not only we need to evaluate the task that we want to focus on our LLM, so like coding, reasoning, calculations, but also we have to take into account that we need to evaluate the safety and the toxicity of our LLM. So basically our LLM system does not have to be just one simple LLM, because it has to have several layers. So we need to have detection of bad prompts, and also toxicity filters and hallucination checks. So it's not only one LLM, but several layers. So how are we evaluating LLMs here in our project? So first we need to define the task. As I said, task, I mean coding, reasoning, language, and then we need to find benchmarks that relate to this task. So for example, here we have several, for example, if we want to evaluate the reasoning of the model, we need to find the benchmarks that tackle this task. There's also maths tasks and other tasks. So if the benchmark paradigm, there's a lot of benchmarks that are currently available that you will have to look for it depending on the task that you want to evaluate. So also, not only you will need to find benchmarks to evaluate your LLM, but also maybe you will want to consider creating a custom evaluation. What I mean by custom evaluation is creating an evaluation dataset with the schema can be question, answer, context, requirements of the answer. And also you will need to define the metrics that you want to use. For the metrics, you maybe want to start with statistical metrics like Bleu and Roche. What happens with these metrics is that they take into account the overlapping between words. So if you want to measure and compare between two answers, two LLMs answers, and these statistical metrics, what some of them do is count the numbers of overlapping words. But the problem here is that it's not a direct implication. Like if there's more overlapping words with the ground truth, does not direct imply that the answer will be better. That's why you want to consider other metrics to evaluate your LLM. For example, embedding-based metrics based on embeddings, or also if you have the capability to have a human evaluation, you will need to consider that. But what is trending right now and what a lot of people are using is LLMs as a judge, basically using another LLM to evaluate your LLM. So I'm gonna dig a little bit deeper on that now. Basically, LLM as a judge is using one LLM to evaluate another LLM. So you're specifying your LLM. This case is this LLM as a judge with a prompt. So as with my experience, I have recollected like key things to put in your LLM as a judge prompt to make it very powerful. So first you need to define clearly your metric and specify as much as you can the definition of the metric. So accuracy, and write the definition that you want to use by accuracy. Then you need to do like a step-by-step evaluation instruction. So guide the model to first you will need to read the question. Then you need to compare the answers. Then you need to check the data if there's missing information, if there's incorrect claims, if they're like the level of detail, and you have to be very specified, and the LLM will check everything that will give you feedback on all the topics that you are like providing. And also you have to have like a very strong scoring system. So define clearly the scale that you want to evaluate. So 1, if the answer provides wrong data. 5, if all the data is correct. So like specify very much like the scoring system that you're using, and also provide like what is the feedback that you want to receive of this LLM. So if you want a scoring table or you want a justification on each thing that you mentioned about the missing information, so you can have all the feedback for the LLM. So here we have a use case that we are here developing. We are fine-tuning an LLM to be climate aware. So this LLM will know more about climate. So we define this task. This is the task that we want to focus on. And then we find the benchmarks that can evaluate this task. So we found several benchmarks that are like in the state of the art about climate, like Climate QA and Climate Bench. But we found that they were not sufficient enough for our task to differentiate between experiments. So that's why we created a custom evaluation that it was based on ClimSide datasets and LLMs as a judge. So what we did in this custom evaluation is create this evaluation dataset and define these metrics. For the evaluation dataset, it was provided by a institution, and it's important to mention that it's representative to the training data and to the real world use case. And the schema was question, ground truth, and context. But you also, if you want to evaluate more things, you can add other features. And the metrics that we created were basically LLM as a generated metrics with all that I mentioned previously. And also we wanted to include a fact-checking metric because it was very important for our answers to be like the data and the numbers and the calculation to be correct. So we wanted to create a fact-checking metric. So This is an example of evaluation. So we have a question. The question of this dataset, this evaluation dataset is, will I be able to plant potatoes in the south of France in 2030 given this location? So in the prompt, I have all the information of the data available, the documents, the requirements of how to grow potatoes, the climate in the next years. So in the prompt, I have all the information that I used by retrieving with RAGs and climate models. And then the LLM uses the question and the prompt to generate the answer. So the answer is potatoes will only be able, this is an example, potatoes will only be able to grow during April and May. So I have the ground truth answer that says more or less the same. This is just a case. And the LLM will judge, okay, the answer, this answer that the LLM generated, the data is supported in the context, so therefore is accurate. So if the data is supported by the context that I provide the LLM, and the numbers are the same, then it's 5 out of 5 accurate. Then we used this evaluation report to extract the metrics. And this is all based on claim site evaluation also. So.
I mean, so basically when we talk about evaluation techniques, we face several challenges. First is related to the evaluation sets and the metrics. So especially for custom domains like climate science, we need curated ground truth. And as Alicia just said, if your evaluation set isn't representative or lacks enough high quality examples, then the metrics lose all statistical significance. Also, as Ivan said, we face a major reproducibility gap. So since LLMs are not deterministic, then the same model can provide different scores for the same answer across separate runs, which makes replicating past benchmarks really hard. And in addition to this, there's an issue of data contamination, as many standard benchmarks like MMLU are already present in the training data of these models. And for the LLM as a judge, we noticed that it's highly sensitive to the prompts or models used, which is actually illustrated in this example. In our work with ClimSite, we fine-tuned pre-trained models, the two variations of Quen3, the 4 billion and the 32 billion, and the Mistral model on ClimSite data, and we used two different judges. First, the Llama 3.1 as a judge. It shows that our fine-tuned model with Mistral on ClaimSide data is the worst, but when we change the model to Flow Judge, it's the best performer. So with this, we kind of proved that the LLM as a judge is highly model dependent. And actually, we changed the prompts as well, and it showed different results. And clearly, we cannot rely on this tool to let's say declare the winner model. And in the same context, but in another project, we implemented a human-in-the-loop approach through a validation portal that we created, which revealed the human evaluation bottleneck. So first, we encountered a problem of scalability because we had 10K Q&A pairs, and we found that validating only 10 pairs is an incredibly time-intensive task from our expert. And then we hit the alignment problem where we realized that what does good mean? Because some experts preferred long and explanatory answers while others wanted strict and concise answers. Also, climate science is vast, so a single expert might know answering questions related to greenhouse gases, for instance, but he might not feel qualified to validate questions that are related to atmospheric composition, for instance. So to kind of solve this, we moved away from just vague subjectivity, because if you just ask an expert if an answer is good, you will get inconsistent, let's say, scores. So we adopted a kind of iterative guideline refinement where we transitioned from just open-ended questions to specific binary questions like is this scientific information correct, or is the grammar correct? And we also implemented topic modeling, so the portal automatically routes questions to the specific area of an expert's expertise, and the expert would choose actually the topic he has expertise on or he's interested in. And this shift is actually allowed us to actually decrease the hallucination percentage in our synthetic data and the amount of time consumed by our experts. So I would say, in summary, there's no single source of truth. Reliability only comes from a hybrid approach where we combine benchmarks, LLM as a judge, and human validation. And human validation is really important in the, I mean, if you would like to have an evaluation. And it's not just a one-time step. I would say it's an iterative process. You refine your evaluation set and your guidelines based on the failures you find and you encounter. Thank you.
Thank you very much, Maisa and Alicia. Is there a question from the audience? I don't see anything on the chat yet. Would anyone like to speak up? Otherwise, I will ask you a short question. If you could ask for anything to improve the evaluation, what would you ask for? Like, would you ask for a bigger benchmark, or like benchmark data set, I mean, or more experts that get involved in evaluating the LLM? What would you ask for?
I would ask more. I mean, this is a tough question because we saw, like, there's, for instance, in Climate GPT, they created data set with experts, and they found that it's the only golden data. At the end, they dropped the synthetic data they generated. So I believe human created data is always going to be the best. But at the same time, there's some limitation in the time and effort put. So automatic tools like benchmarks could be really viable, but it's limiting in tasks. You cannot have a benchmark that can be applied in all tasks. So I would pick experts, a lot of experts.
Okay, thank you, Maisa. Alicia, do you
Thank
want to add anything to that?
I mean, what I found in the benchmarks is that they are very specific to a task. So maybe climate benchmark is very general. So if you want to focus on one aspect of the climate, then it's harder to find benchmarks. So that's a problem that we face, that maybe then you have to create your own evaluation set. So, yeah.
Okay, thank you. I think that's a very interesting
you.
point, and we actually have the developer of Climate GPT, David, here with us. He will be part of the panel discussion. So if you have questions for him, you can also leave them in the chat.
Sure, yes.
Thank you very much, Alicia and Maisa. We are now moving on with Stacy. She has prepared a final interactive activity for you. So Stacy, the floor is yours.
Great, thanks, Xavi. So yep, you're back with me again. Hopefully you can see the Mentimeter. So this is the same Mentimeter as before. So if you still have it on your phone or your laptop, the screen should have changed to this. If you have joined in the meantime, please scan the QR code, go to menti.com and enter that code that you see, or Chara will put the link in the chat and you can click that and just join. So in our last session, we played a little bit with the idea around how hard it is to tell what's real, what's AI, and how confident we feel in those judgments, especially when that language and those visual images feel very familiar and look very familiar to what we're seeing in climate science and services. So now I want us to shift away from spotting AI to something more important for this session as a whole, as we've heard. So what happens when AI starts to sit between climate information and real world decisions? So some of those ethical considerations we've heard about. So in this next part, I'm just going to show you a scenario that I've come up with. So I'm going to click onto that screen now. So in this scenario, an AI tool is providing seasonal forecast information to farmers in a drought-prone region. So what's important about this is that the forecast itself is coming from an established meteorological service. It's not been produced by the AI, so it's just been produced using kind of conventional models. The AI is basically deciding how to explain it, how to simplify it, and how to give that information to the farmer. So it really is on the LLM side producing the explanation rather than the data itself. Hopefully that makes sense. So what I want you to do is think about how much you trust that output. So thinking about that farmers are relying on this output for planting decisions, how much are you trusting that output from the AI? So we've got a scale here, so you can move the scale on your phone or on your laptop from no trust at all to complete trust. And this very much links back to Atia's slide on trust. So that might have swayed the answers you give if you were listening carefully. But basically, I just want to get an idea about how much you trust the output. If you put yourself in the farmer's shoes, if you were given that output from an AI, how much should that farmer trust that output? So I'm just going to give you 5 seconds to put your final answers in. Okay, I see what the general consensus is. Okay, we're pretty much in the middle, which is okay. So we're not really slightly swayed towards no trust at all. So that's quite interesting that we've got that kind of range. So now I want you to think about what would increase your trust. So if you were slightly towards the end of no trust, what would increase your trust in that output? Thinking about the things we've just listened to around benchmarking, ethical considerations, what are the kinds of things that would increase your trust in that output? So I'm going to give you, hang on a second, there's a question in the chat. Do the farmers know if the info is validated? No. So basically, the farmers in this scenario are just given an output from a model, an AI, an LLM. They don't know where the data is from. They're making decisions based on what that AI model has told them. They know nothing about the data or anything. I'm just going to give us 15 seconds just to put your final answers in. So these are some of those answers coming in. So yeah, validation, knowing the author, peer-reviewed. So yeah, a lot of the things that we've just listened to in the keynotes, personal communication, the source, local ecological body check, proof over time, personal experience, human intervention. Yep. Transparency, that's a good one. That links back to our standardization work in Climate Europe. Farmer involvement, yeah, very good on the co-development side of things, historical accuracy. So yeah, you can see that a lot of this, a lot of the things we've heard in the keynotes and a lot of the things we talk about in climate service co-development, there's similarities between the two, and I noticed that in the keynotes as the speakers were talking about LLMs and benchmarking and things, and it's very similar to co-development of climate services. So you can see here validation and personal communication are the top too. So yeah, very interesting. Thank you for that one. So this is just some questions I was thinking about. I guess it's slightly on the negative side, and you can flip this to, so I've got if it was wrong, what happens next? But you could flip it as if it was right, what if that output was right? What happens next? And just thinking around kind of what's the biggest risk if it goes wrong? Who's most effective if that fails? So if the farmer is making planting decisions based on the output and a different climate impact happens, what happens if that fails, and then what would need to happen to rebuild that trust after that. So those are just some questions that I'm thinking about. But as I said, you could equally flip that. If something goes right and that farmer makes a decision based on that forecast and it's the right decision, what happens then? Do they still use that forecast? Are they using that forecast for different different crops and things like that? So that's just something to bear in mind. And then I just wanted to kind of explore what we are most curious or skeptical about in terms of AI. So we've talked a lot about trust and risk, but most people in the room will be coming at AI from different places. So some will use AI all the time. Some might be more skeptical and not have used AI before. So just want to get your thoughts on whether you're curious or whether you're the skeptical things you're thinking about in terms of AI, what are you most excited about? So yeah, most of us will probably be sitting on the fence between excited and a little bit skeptical, but yeah, just give you 30 seconds to put your thoughts in around that. I don't know why the responses. I'm going to show the responses. Yeah, black box. Commercial bias. Yeah, traceability, transparency in the use, hallucinations, what we would do when agents will talk to each other without us. Yes. Biggest direct risk is lack of crops. Most affected are farmers, but also community rely on those crops to feed the population. What would need to happen to rebuild that trust? No black box transparency. Truth becomes more valuable. Human response. Yeah, I like that one. Skeptical, human responsibility, curious, human responsibility. When will we get the first Terminator? A question that I've often thought about as well. To place complete trust in it and then to be let down. Okay, what is the value versus risk of each use? Yeah, these are great. Press space and it's gonna do something. AI is going to do something. So we've got transparency, trust, hallucinations, and human responsibility. So it's grouped your thoughts into four themes there. So I'm just going to move on in the essence of time. Kind of on a similar kind of level, I want you to think about where AI genuinely adds value in climate science and services today and where it's overhyped. So for me, before I started using Nano Banana, I thought maybe in terms of overhyped was image generation because you had lots of errors in the images. I think I said in the first session, you often had like people with like 7 fingers on one hand and things like that. So that's where I think it was overhyped. But I want you to have a think about where you think AI genuinely adds value and then maybe where it's a little bit overhyped at the moment. So again, I'm just going to give you 30 seconds to pop your responses in because I know we're eating into the coffee break. Okay, so we've got value, code and data checking, overhyped, possibly dangerous. Yep, correct. Forward-looking, climate information, makes communication more interesting and interactive, climate change more touchable, potentially impartial, humans are biased, time constrained, have agendas, and knowledge limited. In theory, AI avoids this. Speed, yep. Identifying statistical connections, lagged and spatially remote. Value, helping coding communication more interactive. Yep, not useful for all applications. Yes, choosing when to use AI, it's not always the right time to use it. Add value, overhyped being the solution. Impartiality is overhyped. Yep. Bias is underappreciated. Fast and out-of-the-box thinking brings new inputs. Cool. I'm just going to start grouping these together. So we've got some themes. Cool, there we go. So we've got impartiality, coding assistance, speed, communication, and then we've got some coming in that are uncategorized. So we can share these with you after, but in the because we're running out of time, I'm just going to move on. But yeah, thank you for those. And then lastly, this is to really help the last panel session. So we want you to put your questions in here. So what do you want the panel to answer by the end of the session, essentially? So it could be questions around implementation, maybe something more about governance or ethics, kind of responsibility has come up. Or it could be something you're just unsure about and you want to hear a different perspective on AI. So yeah, these will help Xavi and the panel shape the discussion in the next session. So what I'll do is I'll leave this open so you can grab a coffee and then maybe over the break you can put your questions in here. So don't worry about kind of rushing it now. I'll leave it open and you can come back to this. And I will then hand over to Xavi to summarize this session.
Okay, thank you very much, Stacy. Yes, so we will leave this open to you. I think this question has sparked many questions. Some of them we don't have the answer to. So we are I think trying to figuring it out. The field is moving very fast, and as you have seen during the session, there are many challenges, but also a lot of opportunities. And this is also what we are going to discuss during the panel discussion. So I invite you to leave questions here for the panelists, or also leave them in the chat. We will try to manage them all. And if we cannot answer them during the panel discussion, we will try perhaps to answer them later. So yeah, again, thank you very much to all the keynote speakers. We really appreciate the time you have given us. Given how busy you are, this is not easy, and we really appreciate it. So thank you very much.